We could see stars, planets, galaxies, and glowing clouds of gas, so it was natural to assume that the visible universe was the whole story. But modern astronomy revealed something astonishing. Everything we can directly see appears to represent only a small fraction of the universe. The rest is connected to two enormous mysteries: dark matter and dark energy. And one astronomer played a crucial role in revealing just how strange the universe really is. Her name was Vera Rubin. Rubin was born in Philadelphia in 1928. From an early age, she was fascinated by the stars. While other children might simply look at the night sky with wonder, Rubin wanted to know how those stars moved and what their movements could tell us about the universe. Her father encouraged her curiosity, and she eventually built a simple telescope of her own. She spent hours observing the night sky, developing questions that would eventually shape her entire career. But becoming an astronomer was not easy for her. In 1948, Rubin graduated from Vassar College. She wanted to continue studying astronomy at Princeton, but women were not allowed into its graduate astronomy program at that time. Instead of giving up, she found another path. She studied at Cornell University and later earned her doctorate from Georgetown University. Throughout her career, Rubin encountered obstacles that had little to do with her scientific ability. But she continued working, researching, and asking questions. One of her early interests was the way galaxies were arranged across the universe. She discovered evidence that galaxies were not spread randomly through space. They tended to gather into groups and clusters. That research was important, but it was only the beginning. The discovery that would make Vera Rubin famous came later, when she began studying spiral galaxies. To understand why her discovery was so important, imagine our solar system. Mercury is close to the Sun, so it travels around the Sun extremely quickly. Neptune is much farther away, so it moves more slowly. The same basic idea was expected to apply to galaxies. Stars close to the center of a galaxy should move faster, while stars farther away should move more slowly. That seemed completely reasonable. But when Rubin and astronomer Kent Ford began measuring the rotation of spiral galaxies, something didn't make sense. The stars near the outer edges were moving far faster than expected. Instead of slowing down dramatically with distance, their speeds remained surprisingly high. And this wasn't just happening in one unusual galaxy. Rubin and other researchers studied many galaxies and kept seeing the same pattern. The outer stars were moving so quickly that the visible matter in those galaxies did not appear to provide enough gravity to keep everything together. Something was missing. There seemed to be enormous amounts of matter surrounding galaxies that telescopes could not see. Scientists eventually came to call this mysterious substance dark matter. Dark matter does not appear to shine like stars or reflect light like planets. We cannot simply photograph it. Instead, scientists detect its influence through gravity. We can see what it does, even though we cannot directly see what it is. That was the extraordinary insight behind Rubin's work. The stars were effectively revealing the presence of something invisible. Imagine looking at a spinning galaxy and seeing millions or billions of stars moving through space. If you calculate how much gravity the visible stars and gas should produce, the numbers don't seem to be enough. Yet the galaxy remains intact. The simplest explanation is that additional mass must be present. A huge invisible halo surrounds the visible galaxy. Rubin's observations provided powerful evidence for this idea and helped transform dark matter from a speculative concept into one of the central ideas in modern cosmology. Today, scientists estimate that ordinary matter makes up only about 5% of the universe. Dark matter accounts for roughly 27%. And dark energy appears to make up most of the remaining cosmic budget. That means everything familiar to us, the stars, planets, gas, rocks, oceans, and even our own bodies, is only a small part of the universe. Vera Rubin did not discover the entire mystery by herself, and she did not identify exactly what dark matter is. But she helped demonstrate that the visible universe could not explain the motions of galaxies. That changed astronomy forever. And remarkably, her story did not end with the discovery. Decades later, an enormous observatory would be named after her, carrying her legacy into a new era of astronomy. And that observatory may help answer an even bigger question. If dark matter is real, what exactly is it? Vera Rubin had shown that something invisible appeared to be influencing galaxies, but an even bigger mystery remained. What exactly was dark matter? For decades, scientists have searched for the answer. The difficulty is that dark matter does not seem to interact with light in the same way ordinary matter does. We cannot simply point a normal telescope toward a region of space and see a cloud of dark matter. Instead, researchers have to look for its effects. Gravity is the key. Dark matter appears to influence how stars move, how galaxies form, and how enormous structures are arranged across the universe. It may also help explain why galaxies were able to grow and organize themselves over cosmic history. But identifying the actual particle or substance responsible remains one of the biggest challenges in modern physics. Some theories suggest dark matter could consist of particles known as WIMPs, or weakly interacting massive particles. Other theories propose completely different possibilities. Scientists have even considered the possibility that dark matter could involve an entire hidden collection of particles and forces, a kind of unseen sector of physics that interacts very weakly with the ordinary world. But so far, there is no universally confirmed answer. That is why researchers are using many different methods at the same time. Some experiments search deep underground for extremely rare interactions between dark matter and ordinary atoms. Other scientists study the universe on the largest possible scale. One of the most important tools in this effort is the Vera C. Rubin Observatory in Chile. The observatory was named after Vera Rubin to honor the astronomer whose research helped reveal the enormous hidden mass surrounding galaxies. Its mission is extraordinary. Instead of observing one small region of space in detail, the observatory is designed to repeatedly survey huge portions of the sky. Over many years, it will build an enormous record of how the universe changes. The telescope uses an enormous digital camera capable of capturing incredibly detailed images of the night sky. Rather than producing just a handful of spectacular pictures, the survey is designed to collect an enormous stream of astronomical data. Scientists will use that information to study galaxies, stars, supernovas, asteroids, and many other objects. But one of its most important goals is understanding the invisible universe. The observatory can help scientists map the distribution of matter by studying the way gravity bends light. This effect is called gravitational lensing. Imagine light traveling from a distant galaxy toward Earth. If a huge concentration of invisible mass lies between us and that galaxy, the gravity of that mass can slightly distort the path of the light. The galaxy may appear stretched, shifted, or distorted. Scientists can measure those changes. And from those measurements, they can infer where unseen mass is located. It is almost like finding an invisible object by watching the shadow it creates. Another promising clue comes from stellar streams. These are long trails of stars left behind when smaller galaxies or star clusters are gradually pulled apart by gravity. They can stretch enormous distances across the sky. If dark matter is distributed unevenly around a galaxy, its gravitational influence could leave subtle disturbances in these stellar streams. A gap. A bend. A small change in their structure. Those tiny irregularities could provide information about how dark matter is distributed. At the same time, scientists are studying another mysterious component of the universe, dark energy. Dark matter and dark energy are not the same thing. Dark matter appears to act through gravity and helps explain how cosmic structures hold together. Dark energy is associated with the accelerating expansion of the universe. For decades, scientists have known that the universe is not merely expanding. Its expansion is speeding up. Something appears to be driving that acceleration. We call it dark energy because we do not yet understand its true nature. One of the biggest questions is whether dark energy has always behaved in the same way. Perhaps it is a constant property of space itself. Or perhaps it changes over time. If it changes, our current model of the universe could require major revisions. This is one reason modern astronomical surveys are so important. By observing enormous numbers of galaxies and exploding stars across different distances, scientists can reconstruct how the universe expanded throughout its history. The farther away we look, the further back in time we see. So distant galaxies become records of the ancient universe. The Vera Rubin Observatory will work alongside other major observatories to collect complementary information. Ground-based observations can be combined with measurements from space telescopes, allowing researchers to compare different cosmic signals. Together, these observations may help determine whether our current understanding of dark energy is correct. But the search goes even deeper. Scientists are also investigating the earliest moments of cosmic history. The young universe left behind faint signals that still travel through space today. Those ancient signals contain information about how matter was distributed when the cosmos was extremely young. Future observations